Welcome students to Math 102 Calculus 2. Today we will discuss section 10.11.10, which we will talk about the Taylor and the Maclaurin series. So the goal or the aim of this section is, the goal, so to speak, is to represent any smooth, I will explain what do I mean by smooth function as a power series. Last time we have seen only the geometric series. We can write it as a function. We write the function as a geometric series. If you remember, if you have this function, then you can write it as power series. Now what we want to do in this section, we want to do the same thing for the sine, same thing for the cosine, same thing for the ex, and etc. So I want to write sine x as power series. And that's what we call them, Taylor or Maclaurin series. So that is my goal. Now what do I mean by smooth function? A smooth function, it means it is infinitely many differentiable or infinitely differentiable, which means you can take the first derivative, the second derivative, the third derivative, and so on and so on and so on. All the derivative you can take them, and then you call it smooth function. So what's a smooth function? It's a function that I can take the derivative as much as I like the sine, cosine, ex. Most of our function, we just can go ahead and take derivative after derivative without any problems. So what will be the setup here? Of course, we have to fix the center, and then my function, which can be any function, will be just a power series. So start with c0, c1, x minus a is my center. Of course, I will tell you exactly my center in the question so that you can use it. C3 x minus a power 3, and so on. Which is, if we do it as expanded, as a close or sigma notation form, it should be summation from 0 to infinity cn x minus a power n. And that's exactly what we have here. So my goal is to find C0, C1, C2, C3, and so on. That's the goal for this section. And what is the formula for the Cn? Is very, very simple. Any one of them. All what you need to do is take the nth derivative of the function, substitute it at a, and divide it by n factorial. That's exactly what is Cn. Okay. And then, of course, there is a radius of convergence, interval of convergence, and so on and so on and so on. And this is what we call it, the Taylor series. So here is this one here. It's the Taylor series. Now we have a special case of the Taylor series, which we call it Maclaurin series, and that is if the center A equal to 0. So if I tell you Maclaurin series, this means A equal to 0. If I tell you A equal to 0, what I mean is the Maclaurin series. So Maclaurin series is just a special case of the Taylor series. That's all what we want to say. So A is equal to 0. Now, so this is the formula, and this is how we going to find the representation for any function. Let's go ahead and see maybe a simple example. We start with this one. So I want to take this function and I want to write it as power series. Now, since a equal to 0, my series will be Maclaurin series. If a is not 0, this is Tyler series. Okay, so how we do this? The best way is to make a table. So first of all, what you want to do, remember Ex, what I want to do, I want it to be C0 plus C1 x minus a, which is 0, plus C2 x minus a squared, which is again 0, plus C3 x minus 0, 3, C4 x minus 0, 4, and so on. Which means if we take this shortcut, this is C0 plus C1x plus C2x squared plus C3 x3 and so on. That is what we need. Now the goal is find Cn. Now remember, what is Cn? Cn is just the nth derivative substituted as 0 over n factorial. So the best way to do this, I will make a little quick table up here to see what is my Cn. So here I will put n. I'll start with 0, 1, 2, let's do 3, maybe 4 as well. In the first column, I will have the derivative, and then I will substitute the derivative at 0, and then I will find Cn, which is just this number here over n factorial. I will get the Cn. Now, what is my function? My function is xex. What is the 0th derivative? Is the function itself. So it is xex. Now, what is the first derivative? Just take the derivative of this one using the product rule. So the product rule says that it will be the derivative of first times the second plus first times derivative of the second. Take the derivative again. This is ex plus the derivative of this one again here. This one is here. Is again ex plus xex. I don't recommend you do any simplification. I know you can add ex and to write it 2ex. You don't need this one because later you will substitute. So keep it as it is. Now take the derivative of each one of these. This is ex, this is ex, and this one will give me ex plus xex. Again, you don't need to take derivative. Keep it as it is. Now the next one will be ex plus ex plus ex plus ex plus xex, which is 4ex plus xex, and so on. Now we substitute at 0. If we substitute at 0, this is 0. This will be 1. This will be 2. This will be 3. And this will be 4. So I think you can see the pattern, right? Now, without doing anything, the pattern for me is clear. At 5, okay, and the answer will be 5. So at any n, the answer will be just n. So here we can see a pattern very well going on here. And finally, we find Cn, so we have to divide 0 by 0 factorial. How much 0 by 0 factorial? It is 0. So the first one will be 0. Next, here you have to do 1 divided by 1 factorial, which is 1. Next one, 2 divided by 2 factorial, which is 2 over 2, again 1. Next, 3 divided by 3 factorial, which is 3 by 3 factorial. This is 3 over 6. It is half. And we just write half. Next will be 4 divided by 4 factorial, it is 1 over 6. 5 divided by 5 factorial, this is 1 over 24. And in general, what we have is n divided by n factorial, and that is 1 over n minus 1 factorial. And that's it. We plug in those numbers in the function, we get the final answer. So xex is just what? z0 is 0 plus x squared plus half x cubed plus 1 over 6x4 plus 1 over 24x5 and so on. If you want to write it as a closed form, that's even easier, because it will be just summation from n0 to infinity. Cn, how much Cn? Is this one. Xn. And that's how we find the Maclaurin series for this one. So we need to use the table, we need to substitute, nothing more than this. We can do another example and make sure that we understand how things is going on with those functions. Okay, sinh. Let's see the sinh, and let's see, of course here the center is a equal to 0. Again, what I do is I will write sinh x equal c0 plus c1. It should be x minus a, but a is 0, so I will just write it x plus c2x squared plus c3x3, c4x4, and so on. And now we need to find c0, c1, and c2. The best way is to have this table. Again, we need to substitute it at the 0. And then we just find Cn, which is the derivative at 0 over n factorial. Okay, let's do it here. 0, 1, 2, 3, maybe 4, 5. As long as we need to see a pattern. Now, the first one is sinh x, and then take derivative, which is cos x, and then sinh x, and then cos x, and then sinh x, and then cos x, and so on. Okay. So at the even numbers, it is sinh. At the odd number, it is cos. Now substitute them at 0. Sinh at 0 is 0, and cos is 1. So it will be 0, 1, 0, 1, 0, 1, and so on. So if it is odd, I repeat, if it is odd, the answer will be 1. If it is even, the answer will be 0. So there will be no even power of x. Finally, we just need to divide. The zeros are already zeros. We don't do anything for them. The rest of them is just 1 over 1 factorial, 1 over 3 factorial, 1 over 5 factorial, 1 over 7 factorial. And that's what we get the formula for the sinh. So what is the sinh? What is sinh of x? If the power is even, it will go away. So only we have x plus 1 over 3 factorial x3 plus 1 over 5 factorial x5 plus 1 over 7 factorial x7, 1 over 9 factorial x9, and so on. How do I get this one? I just substitute in the formula. C0 is gone, C2 is gone, C4 is gone. C1 is 1, C3 is 1 over 3 factorial, C5 1 over 5 factorial, C7 1 over 7 factorial. Now, how do we get the sigma notation one? Well, here you have to pay pretty much good attention to me. Since we are talking about the odd and the even, if we are talking about the odd, how do we write the odd? It should be odd over odd factorial, right? This is what we get. Now, how do you write the odd in terms of general n? The odd is 2n plus 1. And if you don't believe me, check few values of n and see if you get this one. Expand this one and check, do we get this one back? If we put n equal to 0, this will be 1 and this will be 1, so we get this. If n is 1, this will be 3, this will be 3, and we get this. And if n is 3, and 3 here, we'll just get this one and this one. So that's exactly how we get the general 1. In this next part, we will do this example. Please watch the next part and let me know if you have any question. We'll do it together.